Good day, ma'am. Good day, classmates. I am Kenneth Buit, Ruaya, and I am tasked to have a discussion about INTERPROSCAN. Within this presentation or video tutorial are the basic concepts about this database. We will be focusing on how this database works and what is or are the mathematics or statistics involved. But before that, I have here a short introduction about this database. So now, without further delay, let us start our discussion about INTERPROSCAN. So why do we need to have such predictive annotation tools like INTERPROSCAN? Databases of protein domains and functional sites have become vital resources for the prediction of protein function. During the last decade, several signature recognition methods have evolved to address different sequence analysis problems, resulting in rather different and, for the most part, independent databases. So diagnostically, these resources have different areas of optimum application owing to the different strengths and weaknesses of their underlying analysis methods. Thus, for best results, search strategies should ideally combine all of them. So this is what happened to INTERPROSCAN. INTERPROSCAN is actually an integration of multiple member databases, and so generally it is being described as a collaborative project aimed at providing an integrated layer on top of the most commonly used signature databases by creating a unique, non-redundant characterization of a given protein family, domain, and functional site. Next, I have a graphical illustration of how our discoveries or inputs when it comes to number of sequences is exponentially increasing over time. So notice, we are to compare two graphs, the graph between UniProt knowledge base and SwissProt, and obviously the slope of the graph of UniProt knowledge base is bigger compared to the graph of SwissProt in terms of their number of sequences. So when it comes to the rate of growth as well, the graph of UniProt knowledge base is faster in terms of number of sequences compared to the graph of SwissProt. So this is also the reason why INTERPROSCAN is very useful and is very convenient to use in analyzing sequences. So now let's talk about the definition of INTERPROSCAN. So INTERPROSCAN is the underlying software that allows protein and nucleic acid sequences to be scanned against INTERPRO signatures. So INTERPROSCAN does not only scan protein sequences but also nucleic acid sequences like DNA or RNA. So now I have here the functions of INTERPROSCAN. INTERPRO provides functional analysis of proteins by classifying them into families and predicting domains and important sites if there's any. To classify proteins in this way, INTERPRO uses predictive models known as signatures provided by several different databases referred to as member databases that make up the INTERPRO consortium. We combine protein signatures from these member databases into a single searchable resource that capitalizes on their individual strengths to produce a powerful integrated database and diagnostic tool. INTERPROSCAN is also extensively used by genome sequencing projects and the UniProt knowledge base to obtain the first test profile of the potential function of protein sequences. INTERPROSCAN is also used in large-scale annotation of proteins, proteomes, and metagenomes. It also combines models from 13 protein resources into a single searchable resource, like what I have said a while ago. Now, we have here a specific length of a sequence. With this, the INTERPRO assigns a protein family. It also assigns domains inside a protein sequence with their specific regions. And finally, it also provides about the protein sites or conserved sites. So all this information contained in predictive models from several databases that are part of the INTERPRO consortium. For example, here, we take this protein family. We can say that it is being predicted by only two member databases. Same thing with the others. In the first domain, it is being predicted by only one member database. 3 member databases for the second domain, and 2 member databases for the third domain. So all this information from the different member databases, which I am going to talk about in this presentation, are integrated in INTERPROSCAN database, which are represented by these gray rectangles. So always remember, databases are combined depending on what they are matching into INTERPRO entries. The INTERPRO consortium contains multiple databases, as you can see in the illustration, and all member databases uses different methods to construct the signatures like hidden Markov models, PPSMs, and patterns, and they have their own particular focus of interests like structural and or functional domains and protein families or protein features such as active or binding sites, and INTERPROSCAN searches a query against the multiple signatures and uses a variety of algorithms to do this like hammer, and blast. So for example, the FAM database, it has hidden Markov models and signatures. So the hammer algorithm used to search a contrary sequence against multiple hidden Markov models, and among specific cutoff is applied, and as a result, you get a hammer output file. This output file is then filtered. First, if the sequence matches two FAM hidden Markov model that belong in the same clan, you can pick one of them with the best score, and if the sequence matches two FAM hidden Markov models, but you know one of the two is listed in the other one, you can allow this overlap. Then you get the INTERPROSCAN output file or the result for your query sequence. So now let's talk about the mathematics applied or involved in INTERPROSCAN database. So I actually have here parallelization. At 3 levels, we have chunking method or parallelization at the sequence level, parallelization at the application level, and the parallelization at the different binaries. But I will just focus on chunking method since it is very evident in mathematics. So what chunking method do is that they make things easier. Like for example, we are to use this chunking method, especially in high degree equations, in finding the value of the unknowns. And so for clearer view, I have here another example for us to be able to fully understand this concept. So notice we have here the equation 0 equals the quantity of x minus 1 times the quantity of x plus 3 plus the quantity of x minus 1 times the quantity of x plus 2. So as what I have said, by chunking method, we are to get the common factor and consider that one as 1, and then the remaining factors will be combined or added depending on its sign rather. So the final equation now is 0 equals x minus 1 times the quantity of 2x plus 5. So the same in a sequence, the INTERPROSCAN will find regions with the same sequence, and so they will consider that one for convenience so that it will not be hard for the database to scan or to analyze a sequence. Now, let's slowly explore INTERPROSCAN database. Just type this URL in Google www.ebi.ac.uk/interproscan, and you will go directly under the services of this database, specifically under the search button. But let us try to go first in home. After searching for the INTERPROSCAN database using the URL that I gave, you will directly be directed under the search button. And however, for us to have a smooth process of exploration, let us start under the home button. And so now let's press the home button. Let's try to press the home button. And let's try to scroll down. So at the top, you will see a little explanation of what are the functions of the database, and I am done with it in my introduction, and so let us skip this one. Let's try to scroll down again. Notice we have a big rectangular space below the search by sequence, search by text, and search by architecture buttons. This is where we can actually type or copy the sequence we want to scan. Now, we have other ways or types of query data to be scanned, like the search by sequence, search by text, and search by architecture. If we try to press the search by text button, you can see some example or guidelines on what to type, like Interpro entry ID, entry name, database signature, and more. However, let's focus on the search by sequence. So let's go back to search by sequence. And always remember, the sequence should be in FASTA format. Now let's try to scroll down again. You will see the example protein sequences button, and if you try to press it, the database will provide examples of protein sequences that will be available in the rectangular space. Now if you want to clear it, just press the clear button, and if you want the database to scan it, press search, and you will automatically be directed under the results button with the entry types that will come out. So now let's scroll down again. We can see another sets of buttons, namely the member databases, entry types, and species. So under the member databases, or the member database, we can see the 13 databases that make up the Interpro consortium, and if we try to press entry type, of course the entry types will come out, like domain, family, homologous family, and more. And if we try to press species, the database will also provide species with their respective number of entries and number of proteins. And so now let's scroll down. So if we try to press view all taxa button, we will go directly in the browse button, and so let's skip that one. So the database at the bottom part under the home button provides the list of the latest and the favorite entries if you already tried to tag one. Lastly, under the home button, we can try to get additional information and updates about the database. So let's scroll down again for you to see it. Here, you can press the read more or read all articles if you want to see some additional informations. So now, let's go to the search button. Press search. Let's scroll down a little bit. Notice it is almost the same on what we had under the home button. So we also have a rectangular space in where we can type or copy our query sequence. So what is new is that we have guidelines or a short reminder, like the protein sequence in FASTA format is with a maximum of 40,000 amino acids, and they also gave an example of the sequence. So now let's continue. Let's go to browse button. So let's press browse button, and let's go down. So let us wait. So let us wait for the database to respond. So what we can see here is actually are actually the list of the member databases, the Interpro types, integrated database, and the gene ontology terms. We also have here the buttons like protein, structure, taxonomy, proteome, and set. So now let's press the results button. let's press it again, and then let's try to wait. So let's scroll down. So under the results button, this is where we can see the INTERPROSCAN search results. But as of the moment, we don't have any data available. But later, as I give example, we will able to learn or to have an overview on what the entry page or the results look like. So now let's continue again to the release notes button. So let's press release notes. And then let's go down and let us wait for the database to respond. And let's try to go down again. So what we can see here are just the additional information about the entry types and the member databases. So the member databases are just below the entry types. And they also provide the version and the signatures and the integrated signatures. Now let's try to proceed. Let's go to the download button. Let's try to press the download button. Let's try to wait, and let's try to go down. Let's try to scroll down. So this is where we can download the software, the InterPro entry list, the InterPro entry details, and more. And they also provide information about the respective description, file name, and format. So meanwhile, under the help button, let's try to press help button. Let's go down. So what we can see here are the tutorials and webinars, trainings, FAQs, and documentations about the database. And so let's proceed again to about button, the last part. Sorry. So let's wait, and now let's scroll down. So lastly, at the about button, what we can see here are the basic concepts about the database. They also gave an illustration about the Interpro Consortium and what are the things it consists. And now we are done exploring. So now for us to have a clear view on how to use the database, so let's try to answer this example. We have here the questions: to which family does the protein belong? Other important domains and sites? And what is or are the function of the protein? So we are given with the sequence which is presented in the PowerPoint presentation. So let's just copy that one into the rectangular space that can be seen in the search button in the database. So notice I already pasted the given sequence, and if we want to scan it now, we can just press search. But for us to have less time, I already searched ahead the given sequence, and so let's just proceed to the results button. So let's go to the results button. So now we have here the results. Let's just press the job ID. Press the job ID. And so we are now in the result for the query sequence. So the length is actually 201 amino acids, and then the protein family membership we have it here. And if you want to try to look for additional information about the protein family, you can just click any of the two, and you will go directly to browse button, and so the database will try to search some information about the protein domain, I mean the protein family. So we have here the description about the protein family, and now let's try to go back to the results of the query sequence. Let's go back to the results button. Let's press again the job ID, and so we're back. Now if you want to know the family, just press the prediction. So for Panther database, we have the retinol binding protein 4, which is positioned in 1 to 199 amino acid. So same goes with the other. For the domain, just press the prediction. We have it here. And then if we want to know the homologous superfamily, just do the same. Just click the color brown horizontal line for the homologous superfamily. And so the database will also try to find the molecular function of the query sequence or the protein sequence, and the biological process and the cellular component. So for my case, there is no biological process and cellular component, but we have here the molecular function of the query sequence, which is the retinol transmembrane transport activity and the retinoid binding. So that's it for the result. And so how I have here now the summary for the result. So now we have here the summary of the result. We have the homologous superfamily, which is the calicin or calicin rather. We also have here the domain and the site, which is the same. We have lipocalin, and for the molecular function, we have the retinoid binding and the retinol transmembrane transporter activity. So that's it for my discussion, and I hope you learned something from it.